request audio. So this is work presented at OWASP 2006 by Martin Johns. It's actually initiating a token-based approach, but running it as a client-side proxy. So the client is actually under control of the token-based approach. What does it do? It intercepts requests and responses. It actually verifies whether the responses include the tokens, and if not, the countermeasure is to strip cookies and to strip HTTP authentication credentials from the request. And it was also a unique solution in the sense that it was protecting the intranet by using an external proxy. When we are looking to request Rodeo and all techniques that are residing in the same space, is that it are actually working pretty well in a classical web application, where you're easy to identify which are the links that will generate new requests. You enhance them with a token, and then you see in the outgoing request whether the token is present or not. They typically behave very badly in a Web 2.0 application, because it's very hard to try to intercept responses and to see in a large bunch of JavaScript to see which lines will actually generate new requests and to include tokens on them. This is not only for request Rodeo, but we see the same happening for all the token-based approaches that are not closely connected with your application itself. So token-based approaches work really well if they're nicely integrated into your development environment, if they're nicely integrated into your AJAX environment. So what are the other mitigation techniques on the client side? Well, you have a bunch of extensions that try to help you against cross-site request forgery. And the typical mitigation technique is blocking requests or stripping requests along the lines of request Rodeo. And we see that it's very hard to find the right balance between security and usability. For example, CSRF Protector and anti-CSRF doing a good job in making the web still usable and having a very good user experience, but they're only limited to protecting against the subset of cross-site request forgery. On the other hand, request policy and NoScript have providing a better security solution. They're protecting you much better against cross-site request forgery, but will be very hard out of the box to deploy these solutions and having a usable internet experience. So you will have to configure yourself which are the optimal policies in order to browse the internet. Even, for example, surfing to Google and linking on some clicks where you have redirects could already degrade your user experience in request policy, leading to, for example, a block on sending a request, not fetching the page itself. So that's the reason why we were actually investigating into CsFire. And we came up with 3 main requirements for client-side mitigation techniques. The first one is we believe that the plugins or the extensions should be completely independent of user input. On one hand, you had like 1/3 of the request is cross-domain. You can't ask for each request what you have to do. Secondly, most users don't know what to do. You saw already in the presentation of the keynote, 50% just proceed while there's a warning about security. Most of the end users don't know which interactions to other websites are necessary or are safe to use. Secondly, it's very important that the solutions we deploy are usable in a Web 2.0 context. And we saw most of the current solutions don't work well in mashup context, in a dynamic behavior of an AJAX solution, or working together with single channel solutions. And the third requirement is that we have to find a secure by default, that we have to block as much as cross-site request forgery types, although we have the usable experience of being workable in a Web 2.0 environment. And this is actually the baseline of working on CsFire. So CsFire is client-side mitigation technique developed by our research group and mainly builds on the concepts of request Rodeo. But in that sense, that it's porting it to the web browser because there's much more context information available within the browser. And our main purpose is to find a good balance between security and usability. And this research is actually described in a paper presented in February 2010, and you can go to our website to download that paper to see more technical insights in how we constructed this solution, why we believe this solution has some added value. So let me present how it actually works. You have your browser with your browser core and context contacting a web server over an HTTP channel. The first step in doing an enforcement is, of course, gathering information. So we try to gather as much information as possible from our browsing context, for example, which DOM element is triggering the request, but also within the HTTP channel, information about the cookies, about HTTP authentication. So we have all the information about the origin, destination, which method is used, whether there are cookies or HTTP authentication, whether the user actually clicked a link, or it's just an automatic request that is sent out by the browser. So we now have all the information necessary to make a decision, and the next step is actually making the decision within our browser. We have different actions we can actually associate with our decision. We could simply accept the request with all the implicit credentials attached to it. We could block the request. We could strip cookies. We could strip authentication headers, or have a combination of the last two. So we actually decide what we have to do in a current situation, and then we're enforcing that on the HTTP channel. So the main question, what is a usable security policy in this context? So the first thing is that if we have a GET request without any parameter that is user-initiated, we accept by default. Why we are doing this is if you're surfing to Google, you're looking for the facebook.com website, you find a link, you click, the end user might want to be still logged into the website when he's clicking that link. This is still something that is under consideration, and we might simplify this by later on also stripping requests, because it's only a very limited set of requests fulfilling that purpose. So we're talking here about all the cross-domain traffic. All traffic that is not cross-domain is accepted by default. What we're doing for all the other parameters, for all the other requests that are not user-initiated, is actually stripping all the cookies and all the HTTP credentials. So it's a quite simple policy. We try to strip as much as possible from cross-domain requests, and we have one exception to actually improve search results on, for example, google.com. So we prototype this version as an extension for the Mozilla platform. You can download at the Add-ons website of Mozilla. It's called CsFire. And if you compare the policy to existing policies, it looks as follows. So on the right side, we have the CsFire policy. If you compare it to request policy will make the decision whether it's user-initiated or not in order to see whether the request should be accepted or blocked. The request policy accepts all the user-initiated requests. It also means if you can trigger a user in clicking a link, he is already vulnerable to cross-site request forgery, because the user should check itself whether the link will be cross-domain or not. If you're submitting a form on a web page, you have no clue where you're submitting the form to. Actually, with the hidden fields, it could submit it to another domain. You could be vulnerable to cross-site request forgery. A second observation with request policy here is that it's blocking all the non-user initiated content, which leads that all requests or web pages incorporating images from other domains will actually have no images included in your website. So you will block a lot of content. You will actually break the World Wide Web of linking to each other. If you're comparing it to an anti-CSRF, then you will see that the main decision whether something should be allowed or not is based on HTTP/HTTPS distinction. And you see that for cookies over HTTP, no harm can be done. They will be accepted, and all the rest will be stripped. And this is, in our mind, a strange decision, because we believe most of the websites are still using HTTP, and most of the attacks typically happen via cookies. If you remember the statistics, only 2 domains were using HTTP authentication. So this is how CsFire works, how the policy is. Now, of course, we try to make a good evaluation to see whether the policies are actually working, whether we took the right decisions there. So the first thing to do was actually seeing, are we mitigating against all possible forms of cross-site request forgery? And to do so, we actually looked at all the standards of HTTP, CSS, HTML, and JavaScript to see what are possible attack vectors for cross-site request forgery. We made up 59 attack scenarios for cross-site request forgery, and we have an automatic test to see whether a browser with its extensions is vulnerable or not against cross-site request forgery. Secondly, we started with a test group of students and personnel at university, about 60 people, and they were using our plugin infrastructure for several weeks, and it was used to detect issues that we had in the balance between security and usability, and they were also able to provide the necessary feedback via repos, but also via direct contact. And actually, we used that to fine-tune the policy we present today. Also, we put up our software on the Mozilla Add-ons website, and we had, since the release in February, about 6,300 downloads. And we see that on a daily basis, more than 1,800 people are using our extension. We got some positive feedback from the end users, but we also got some additional feedback on including server policies, and that's a concept I will explain a little bit later. So we got positive feedback on that part as well. What we are looking, well, we have an extension that seems to use Web 2.0 websites and signal sign-on mechanism in a pretty good way, but we also saw that there was some pending issues with the policies we presented. And the main issue that was reported was actually websites spanning multiple domains. If you're looking to google.com, if you're in Belgium where you're surfing to google.be, then you're redirected to google.com and you're redirected back to google.be all the time. So one company is spanning multiple domains. If you're stripping in cookies in request going from one domain to another, you end up in problems. And we also saw that it's very hard for us to actually differentiate between that type of interaction between two double-level domains of the same company and an attack. It's not easy to say this is a malicious request, whereas it should be benign in the context of one company. So we need additional information about intended cross-domain requests, and we need actually that to be expressed as a server policy. Those two domains are allowed to communicate to each other over the boundaries of the origin. And to include that information into CsFire, we're actually working with a policy server stating server policies. And at this point, I think we have only 20 server policies included for all the users we have right now in our testbed. Users can also include local policies if, for example, internally in their company, they also want extra information about certain websites that need to interact with each other. And with that information, that evaluation we did until now, I'm coming to the end of my presentation. So I presented some traffic analysis concerning cross-site request forgery and cross-domain traffic. What's important to know about that traffic, we didn't have differentiate between benign traffic and possible attacks within the traffic, because I think it's not important in this sense. We just need to shape out what is the normal nature of interactions between different sites. In the work we presented today, we also tried to identify the requirements for a client-side solution, and most important there is the balance between security and usability. And I think with CsFire we have a balanced client-side solution. It's secure by default, it's user-independent, and with the server policies you can have even more fine-grained policies deployed on your client side. We implemented this as an add-on for FireFox. We did a technical evaluation on the different attack vectors for cross-site request forgery, and we have also a real-life evaluation with lots of test users. I also included some references in my presentation that were indicated up front, so it's interesting to read. But if you're reading the SS paper, you will also find much more references to interesting material on this topic. And I encourage you to download the extension, to install it on your own system, and actually provide us with additional feedback on how usable it was, on which website it could break, because together we can actually improve the client side for cross-site request forgery. And with that information in mind, I would like to thank you, and I'm happy to answer some of your questions. Thank you. Yes? Yeah. At this point, so the question is, what about other browsers? So at this point, we only focused on FireFox because it's the main platform that we're using within our group, and that also was easy to extend. We're actually investigating the extension frameworks of other browsers at this point to see whether it's easy to port to, for example, Chrome or, for example, WebKit. At this point, I don't think we have the right pointers as an extension to do all the network operations within the browser, but we're hoping to find a solution in the near future. So it's certainly some track for future interest for us. We would also like to see how we can actually port this information to the client side on mobile devices, because we see more and more interactions happening from your mobile device, which is a small browser that might not be that well protected, and I think protection against cross-site request forgery there is also essential. Other question? Yes? Yeah. Yes.